Let's wait for 5 minutes. We should start. So welcome to the live interactive session of week 7. Uh, this is the NPTEL NOC for the EE-28 signal systems. The course instructors we Professor Shriman, Professor Prashant Kesha. Over to the guidelines. Eric exhibits the last week's lectures that covered the following topics: discrete-time LTI systems and sampling. And I hope you all would have gone through them. And after going through them, you would have attended the assignment day before the session. So, take from this has been going today, which is for the figure, you need to compute the value of y of 0, y of 1, y of 2, and y of 3. Where this y of n is x of n star h of n. And this star denotes convolution. And this question again. Okay. So how do we start? We need minus 7 plus 1. First, pages. What can be interested? We are interested in y of n. Mean convolution of x of n and h of n. And what is x of n? X of n is there are two sample points, right? 0.5 and 0.5. Right? This one is equals n equals to 0, difference squares equals to 0. And then the representation of h of n would be following. We'll have 3 sample points, each of value 1. And this would be a sample point for n equals to 0. And likewise, this is for n equals to 1, n equals to 2. Right? That's your option. Now, we are interested in finding viable. Right. One way of doing this would be to note from definition, right? Viable summation working with k varies from rising to x of k, h of n minus k. Right. We can either watch it using this, which is actually the discrete time relation definition, or we have one eight what should I say, shortcut, which I'm sure must have been discussed in the lectures. So idea is um, a row entries will be the h of a, right? So we have 1, 2, 3 h of x, so corresponding to 3h of n values, each of those. Then my column trees would be x of n, or x of n, I have to do is here. Now then we get the ij entry. What we do is we multiply the ith row by the jth column. Okay. So okay, the value corresponding to this expression will multiply h of n and x of n corresponding h of n. Okay. So this will be 0.5, 0.5. In fact, all the inputs will be 0.5, right? Because h of n is 0.5 and x of n is 0.5. And what do? We do is we sum it. So I'll be summing the increase that touched the highlighted numbers. Okay. So my y of n would be, so what should be the first entry of y of n? 0.5, right? Similarly, what should be the second entry of y of n? They will be added, right? 0.5 plus 0.5 is 1. Likewise, will be added again. 0.5 plus 0.5 plus 1. And then I have last entry, which is plus 0.5. Okay. So those is the entry corresponding to equals to 0. And then this is variable equals to 1. This is variable equals to 2. Then equals to 3. Okay. This was last in the question. Right? So what should we, and we can so show those graphically. So if this is one thing, and this is one. So at n equals to 0, I have 0.55. is bound effect. And then n is equals to 1. At n equals to 1, I have this 1. So similarly, at n equals to 2, I will gain the 1. At n equals to 3, I have 0.5. And for the scale, it should be easy. Notice how is value of daily look graphically. Okay, all the other entries are same. But n equals to 4 and 0, 5, 0, and likewise so on the both sides. So what should be y of 0, y of 0 goes 0.9. What about y of 1 is 1. Y of 2, that is also 1. And y of 3 is 0.5. So I finishes your question 1. Which option is correct? Correct answer is option C. Sorry. Between C. In this question, you need to determine the value of y of 1 and y of 2. If there's y of n is equals to x1 of n plus 3 times x2 of n, right? And you have been provided x1 of n and x2 of n. So what should be y of 1 and y of 2? Y of 1 would be x1 of 1 plus 3 times x2 of 1, right? Using this given formula. Similarly, the y2 of y of 2 would be x1 of 2 plus 3 times x2 of 2. Let me know what is the answer. So This is short for. So what do we need to find? We need to find y of 1 and y of 2. Right? Using this definition, y of n will be 1 of 1 plus 3 times x2 of 1. Similarly, your y of 2 would be x2 of this x, sorry, this is x1, x1 of 2 plus 3 times x2 of 2. And your x1 of 1 is, notice your x1 of 1 is 1. Your x2 of 1 is again 1. So this will be equal to 1 plus 3 times 1, that is 4. The y of 2 would be x1 of 2. What is x1 of 2? This, right? Corresponding to the x2. And what is x2 of 2? This is only equals to 2. The corresponding value is 2.5. Okay. So the answer should be x1 of 2 is 1 plus 3 times x2 of 2 is this 3.2.5. What is 3 times 2.5? That is 7.5, right? And 7.5 plus 1 is 8.5. So which option is correct? The one was 4, 8.5. So it's option B, right? Let me know if you have any doubt on this one. If not, we can proceed. So this is your x of a. Okay, and x of n is given by this alpha raised to power a u of a, where this alpha lies between 0 and 1. Yeah, h of n is equals to u of n to determine the impulse response by a. So this is the question. So your x of a is alpha raised to the power of negative. In this alpha lies between 0 and 1. What is your h of n? H of n is u of n. Okay. It's given in the question. We need to compute y of n. Y of n by definition is x of n convolution h of n. Right? So your y of n would be equal to what is x of n convolution h of n by definition? It's a summation varies from minus infinity to infinity x of k h of n minus t. Right? And then now I substitute values. Y of n would be what is x of k? See, x of n is this. That x of k should be alpha power k q of k. H of n minus k. H of n was u of n. So x of k, sorry, this h of n minus k should be u of n. Now pay attention. U of k samples like this. And starting from k equals to 0 all the way to infinity. What about u of n minus k? Again, it will start at k equals to n. Argument should be 0, and n minus k is 0 and k is equals to n. So this is my scale of k. This start at n equals to 0, sorry, k equals to n. And then k should decrease, right? K would decrease as n minus k would increase. So that's why examples would be n minus 1, n minus 2, and so on. So given that you know this now, what should be the limits of this summation? Right. U of k is this. U of n minus k is this. So this signal will not extend all the way to minus infinity since it's U of k starts from k equal to 0. So it would start from k equal to 0 and all the way to n, right? So we won't go all the way to 1 because U of n minus k is 0 beyond this k equal to 1. That is why limits of this summation would change k equal to 0 to k equal to n, right? And I'm left with this alpha power k. Evaluate this summation. You need to evaluate alpha power k. Summation k varies from 0 to simplify the matters, expand the summation. Will look something like this, right? All the way to alpha is over n. Does this look like a GP? For the common ratio alpha and first term equal to alpha is for 0. Since alpha lies between 0 and 1, this alpha power 0, safety limit is 1. Right? So see, this is 1 and common ratio R is alpha. How many terms are these? Right, I have a formula for summation of n terms of a GP, but I need to first determine how many terms are there in the GP, right? So how many terms do I have in this GP? Okay, I guess I'll start from here. Alpha raised to the power 1, alpha raised to the power 2, so until alpha raised to the power n. These are n terms, right? And then you have 1. So I have n plus 1 terms, right? Is that clear? So this is sum of n plus 1 terms of geometric progression. And if you remember, you know this formula, right? Sum of n terms of a GP, this is well known. It's equal to a times 1 minus r to the power n all divided by 1 minus r, right? Sum of n terms of n, but we have n plus 1. So we'll replace this n by n plus 1 in this formula. So we have is n plus 1, that is equals to a 1 minus r raised to n plus 1 all divided by 1 minus r, right? And that would be a y of n, right? Y of n would be 1. So let's write that y of n would be equal to a is 1, right? So a is 1. 1 minus what is r? R is alpha, right? Alpha power n plus 3 all dot 1 minus alpha. Right, and there's your thing. Yeah. Modulus of alpha should be less than 1. And since alpha is between 0 and 1, the modulus of alpha is also less than 1. This is condition for this series to converge of this expression. Yeah, that condition is satisfied. So the obtained expression for y of y that is valid for all n greater or equal to 0. Right? So which option is correct? It is safe, right? Is it? Yeah. More often because the series would start from n equals to 0. That's why you see this. Right? Because we started. So we are done with question number 3. What about this question number 4? We need to determine what's y of n. Should this y of n be will know that have two systems in cascade here, and H3 of n is parallel with the cascade of H1 of n and H2. Fine. So to simplify this, what we'll do is we'll first write an expression for this one. Right. This is your example. H1 of n and H2 of n are in cascade, right? So what is the resulting impulse response when two systems are cascaded? Is convolution, right? So I will have convolution of H1 right? And we'll keep this H3 of n analytics. Now what is y of n? Again, see, to determine y of n, first we need to find resulting impulse response. Now these two impulse responses are in parallel, right? They are in parallel. So if I were to replace this by single response, impulse response, what would that impulse response be? Suppose this is h of n. What should be the expression for h of n? What should be this? Would be sum of the two, right? Since these impulse responses, sorry, since these systems are in parallel, so we'll add the impulse responses. And when they were in, when the systems were in cascade, we convoluted these impulse responses. H1 of n, convolution of H2 of n, and H3 of n. Right. But the job is not done if we need to find y of n, right? And y of n is convolution of this capital H of n with x of n. And y of n is x of n convolution H of n. And so which option should be correct? Should be option A, right? Why? Because we know that this convolution operation is distributive, right? It follows distributive property. So when I convolute this x of n like this x of n would be convoluted with this term, and x of n would be convoluted with this term, or plus something. And now let's precisely what this is. Hope this is clear. Let's so very move on to the fifth question, which is this discrete-time delta function. Right? Is it known as In A is there are delta function, objective is Dirichlet's delta function. Third option is Fourier delta function, and the fourth one is Kronecker delta function. So I'm sure we would have seen this Kronecker delta function somewhere in physics, I guess. So what is this Kronecker delta function? This is a function of two variables, right? That are usually two non-negative integers. And the function is one when those two, should I say, variables are equal, and it's equal to zero when they are not equal, right? That is precisely how we define this Kronecker delta function. So this is how we define Kronecker delta function. Is a function of two variables, what is it? That are usually two integers. Function is equal to 1 if the variables are equal, and it's zero otherwise. So when it is zero, when the variables are not equal, right? So mathematically I can write del ij if these ij are the two variables that I'm talking about. When is it equal to 1? When this I is equals to 2, right? And when is equals to, when is it equal to 0? This is equal to 0, then this I is not equal to 0. Okay, let's take an example. Suppose I have del 1, 2. What should this del 1, 2 be? When I is 1 and j is 2. I and j are not equal, right? In del 1, 2. So del 1, 2 should be 0. Because 1 is not equal to 2. Likewise, what about del 3, 3? Del 3, 3, we have I and j equal to 3, right? They both are equal to 3. So they both are equal. So this should be 1. Right? reason we should write because 3 is equal to 3. Okay. Now, given that we briefly recap the conical delta function, the question asked us what this discrete time delta function is known as, or what it is for. Right. And I'll write it as follows. Okay. So this discrete time delta function, the del of n, right? It's actually a special case of this two-dimensional conical delta function del H, where this one of the two indices is equal to 0, right? And when one of the two indices, I and j, okay, say this was your conical delta function, right? In special case, and this is two-dimensional, right? But what if one of the two indices is 0, right? Suppose this j was 0. When would this del I0 be 1? When I would be equal to j, right? But since j is 0, so this would only be equal to 1 when this I is equals to 0, right? So for the rest of the entries of phi, I'll have this conical delta function as 0. And when this I would be equal to 0, I would have 1, right? And this is precisely what discrete time delta function is by definition, right? Del of n is equals to 1 when n equals to 0, and it's equal to 0 when n is not equal to 0, right? So that is how this conical delta function can be thought of as a special case of discrete time delta function. So let me summarize what I said. Yeah, we are discrete. Yeah. Discrete time delta function del of n represents a special case of a two-dimensional conical delta where one of the uh, we shall write this is equal to 0. Okay. So mathematically, how would we write this? Your del of n is equivalent to del of n 0, right? That is equivalent to del 0, right? We are not imposing any condition. Either I could be 0 or the j could be 0, right? And where this varies from minus infinity to infinity. Okay, now what about this particular equivalence for a general discrete and delta function? By general discrete and delta function, I mean that del of n minus k, right? It's not necessary that discrete time delta function would be equal to zero and n equals to zero. What if it's a shifted version of that, either delay or advance? Suppose we have a delta function at n equals to 2. Mathematically, I would represent that by del of n minus 2, right? Can I mean, do I have an equivalent representation in terms of conical delta function for del of n minus 2 or del of n minus k in general? Turns out it is, and in general, del of n minus k or del of n k, because what is del of n minus k? This is equals to 1 when n is equals to k, right? And that is true for this as well. So this okay, this is fixed, right? The n will vary from minus infinity to plus infinity, and it would be equal to 1 at this k, when it takes k. Likewise, and since this and this is same, I mean, can equivalently what you can write is del of k minus n, right? Because del of k minus n and del of n minus k same. So this is equal to this, or this is equals to del of. This is understood, right? Because this delta function is an even function. So this system and again n takes values. This I should write this. Oh, n takes also minus infinity to percent. Okay, so we are done with question number 5 as well. What about the next question? Question number 6. So we did in the previous question. Answer was coordinated under question 2 and discussed in detail. Thank you for justice. Yeah, that's fine. So you need to find a inverse responsive for system whose output is u of n when 10 of n is applied at the input. So this is clear as a simple boundary. By definition, what is the impulse response of a system? Impulse response of a system is output when impulse is applied at the input, right? And for a discrete time case, this will be del of n. When del of n is applied at the input, whatever you get the output, that is your impulse response. And in this case, it is given that the system has got an output of u of n when del of n is applied. So this u of n is what the impulse response of the system is. Right. So we'll take option B, right? U of n, because that is what the output was corresponding to del of n. Now what about the next one? If periodic sequence of data has a Nyquist sampling frequency of 1 megahertz. What is the Nyquist sampling frequency of this signal? That is obtained by differentiating the signal with respect to time. Okay, dx by dt. So we'll proceed distribution and response. This is question number 7. Will the given signal was x of t, right? So it's periodic will write there's Fourier transform, right? I mean, we'll talk in terms of its Fourier transform, like our famous better picture. If x of t has a Fourier transform, x of j omega, what about dy dt of x of t? What about this? You know that the Fourier transform would be j omega times x of j omega, right? This comes from the properties of Fourier transform, which we have discussed many times. So, what is happening in the frequency domain? The amplitude changes, the phase changes. Does anything happen to the frequency? Does anything happen to omega? Nothing. Right? So frequency remains unchanged. So nothing happens to the bandwidth of a signal. Right? So the sampling frequency would not change. Right? In general, differentiating a signal in the time domain, it does not any frequencies that are not present in the original signal. Neither does it remove any frequency component from the original signal. What it does, what this differentiation does is it just changes their relative moments. Right? Won't change frequencies, right? Frequencies would remain what they were in the original signal. So our bandwidth would be unchanged, right? And therefore, this Nyquist sampling rate will not change. It would still be 1 megahertz, which was the case with constant signal. So which option is right? Option A, right? Yeah. So, and because only phase change. Frequency unchanged. We are not creating or removing any frequencies that were present. So only thing that we are doing is we are just changing the relative levels of those frequency components. So yeah, option A was correct. Now, see, had there been a frequency shift in this signal by some operation, then bandwidth would have changed, right? But in this case, omega remained omega. And we know that we have some properties to which this x of omega can become x of omega planes. In that case, some different frequencies will be introduced, apart from the ones that were present in the original signal, right? And for that case, our bandwidth will change, and accordingly, we will have to determine this Nyquist sampling rate. Okay. See if we could take one such example. We can think of such examples, right? What about this one? If x of t is a signal where the fundamental frequency 40 gigahertz, you need to compute the naive sampling rate for y of t, where this y of t is 40 times x of t plus 4 times x of t times. There is this time shift operation. But what does this time shift operation do? Time shift operation would only introduce the complex exponential factor, right? Complex exponential factor gets multiplied in the frequency band. So I'm trying to say is if your x of t had a Fourier transform x of omega or j omega, if that was your notation, then this y of t. C equals to pi plus y. What would be y of j omega? That would be equal to 40 times Fourier transform of this. And so 40 times x of j omega now plus 4 times x of t minus 4. So it would be 4 times x of t minus 50. That would be x of j omega multiplied by that factor, right? So shift is 4. So and the factor that gets introduced due to the time shift and version x of t minus. Right. So is there any change in the bandwidth? No, right? We can write this as x of j omega 40 plus 4 e to the power minus j4 omega. Right? Nothing happens to the bandwidth. Right? So when the Nyquist sampling rate change, it won't. Right? What was the Nyquist sampling rate for x of t? Nyquist sampling rate is double this fundamental frequency, right? It's equal to twice of this. So since the fundamental frequency of the original signal was 40 gigahertz, Nyquist sampling rate would be 80 gigahertz. Right? And that 80 gigahertz would be the Nyquist sampling rate of y of t as well. And so firstly we'll write that bandwidth is unchanged by similar arguments. Nyquist sampling rate of x of t and y of t, both, right? Although in the question they are only asked about y of t. That would be 2 times omega naught, that is 2 times 40. Right? 2 times 40, that is 80 gigahertz. So the correct answer is this one. Okay, so let me take an example. So since we saw two cases in which the bandwidth was unchanged, what about the case when the frequency changes? Suppose you had some Nyquist sampling rate There is some microsampling for x of t, right? And I asked you, what is the microsampling rate of y of t? Where this y of t is given by x of t times this e to the power j omega. Suppose this had a microsampling rate of 1 megahertz. What would be the microsampling rate of y of t? In this question, this is not fixed, right? I mean, the frequency won't be same. It will change, right? Because frequency shift will be introduced in the frequency domain, right? And that comes about from the properties of flow and transfer. So then you can determine through that shift what would be the frequency shift, and then you can proceed and determine the microsampling rate. So the fundamental frequency of the y of t, double that, and you'll get the microsampling rate of y of t, right? So here microst, suppose here microst sampling rate in a set. Here microsampling rate will not be, what should I say, 1 megahertz. Right? So there are these questions involved in as well. So now what about linear constant difference equations, LCCDE? So it is an equation that describes the relation between the input and the output of the discrete time system. Right? It describes the operation of the system in the time domain, and it provides a method for computing the response of the system to an arbitrary output x of v. The reason why I'm discussing this LCCDE is that the next two questions will be simple ones, and they will be on this LCCDE, and they will be, and we need to just use a definition for it. So an nth order linear constant coefficient difference equation is expressed as shown. Right. So summation k varies from 0 to n, ak y of n minus k, that is equal to summation k varies from 0 to capital N, ek x of n minus k. Inputs, outputs. So for example, can have this case, right? What is the order of this, what should I say, this LCCD equation? The order is determined by this, right? Capital N, right? Here, the maximum value of this scale is 1 order is. So here, the maximum value that this scale takes is 1, right? So the order is 1. And this is a first order difference equation. So let's quickly take some questions on this. So for a linear constant coefficient difference equation, LCCDE, the response is IIR, the infinite impulse response. Under what conditions? This is your LCCDE. Under what conditions will the impulses will be informed? Will write the sleep for the infinite impulse response. Our system should be recursive, right? And our system should be recursive, and it will be recursive when we have terms like A1, y of n minus 1 a2 y of n minus 2, I mean so on. These terms should exist for systems, for the system to be recursive, and hence having a response that is infinite in this response. So in other words, the order should be greater or equal to 8, because this is what the order is, right? Also, you are careful. If I had only this term, then the order would be 1. If this term, then the order would be 2. I mean, even if I have both, the order would be 2. It's the highest k that occurs. Okay? Now, the system to be recursive. So if n is greater or equal to 1, which of these options should be correct? Is this one, right? You say k should not be equal to 0 for at least one k greater than 0. Because if this condition is satisfied, then I will have an order that is greater or equal to 1. If this condition is not satisfied, then the system is not recursive. Right? I need a non-zero coefficient k for at least one k greater than 0 for the system to be recursive, and hence the response will be infinite in this instance. Similarly, what about this question, question number 10? For a linear constant coefficient difference equation, again, it is the same equation. You need to determine the condition under which the response is finite impulse response. Okay. For this finite impulse response system, should have a non-recursive system, right? And when will the system be non-recursive? System will be, this will be the last question. Okay? System will be non-recursive. The system will be non-recursive when those terms that I talked about. You won't have any of these terms, right? I mean, there should be only y of n. K should be equal to 0. You should not have any AK for k greater or equal to 1. So in that case, this seems correct option. Okay? AK is equal to 0 for k greater than 1. So k equal to 1 onwards, all the AK coefficients are 0. Under that condition, in other words, that would be belonging to order being 0, right? So under that condition, the system would be non-recursive, it's finite in its response. And so which term will exist mean all the terms that are greater than equal to 0 are 0, right? Because the AK coefficients are 0. So we'll be left with A0, right? So only A0 y of n, y of n means case y of n, right? Only this exists. And A1 y of n minus 1, A2 y of n minus 2, so on 0. Okay, the that is your output does not depend on the on any of the variables. But does not depend on any of the variables. And when the output will not depend on any of the previous inputs, we have a non-recursive system. And hence, system will have finite impulse response. So that finishes 10th. Yeah, done with set of questions. So if you have a question, once we will end the today's session. If there are questions, we can end today's session.